Dobry din. In fact, I do not know Russia well, but I try. I'm now learning. Today I'm here to discussing about the future, in fact, and maybe this session would not be really technical. It would be something just for reviewing some further steps that we have to follow the further of application security. And this is the important matter that we have. So first, let's think about this question. And in fact, we have a gift for the answer of this question at the end of this session. Who are the parties to this war? In fact, application security is not a tool, is not an approach. In fact, it's a war. It's a war now between two parts. And a human is one of the, in fact, one of the this war. Who are these parties? Think about that. I just want to know about your idea, about your creative ideas, because the game is now is changing. AI agents are evolving in this war, and this is really important. We should consider about agents. So, this is Milad. I am Milad Kaysari, and I'm working in application security and DevSecOps segment. So I would be really happy to be connected with you guys, and you can scan this QR code or you'll find this presentation on Positive Technology, I guess, website. So let's start about part one. Before starting discussion about application security and future of that, let's back to the start. We first need to find what was the application security and when it started. This is the bug. This is the real bug. And this is the first bug that human found that. In fact, this bug had caused some issues in computing. And this is why we say it's bug, because it really was a bug. So we call it a bug. And this is a historical point of computation in fact, our industry. So let's start about the application security and modern type of that. It starts in 2000s. It backs to around 25, in fact, years ago. So when it started, application was really simple. The coding, the programming was too different. So application security is kind of this old man. But this is not only an old approach. Each year, it will be changed. And this is really important. We, as application security engineers, as a developer, we need to optimize our mindset to the newest approach of application security. But when we want to talking about the history of application security, we should mention to OWASP Top 10 that maybe it changed the application security. They introduced multiple recommendations for this segment, and it would be really, really helpful, community-driven concept. Nowadays, OWASP are producing multiple topics around application security and also DevSecOps guidelines that are really important to us. We had old and traditional approach that was a waterfall development. So nowadays we do not use that, but our previous application security approach was in fact built according to this approach. And this is why I just mentioned we need to optimize our mindset about application security each year, or maybe truly it's each day, not each year. So application security is an old man, but has a young mind. And we should think about this contrast between these two. The era of patchwork, in fact, security was something like that. We had some requests, we had some clients that wanted to connect to applications. So they initiated request and they sent that to the application. We had, and also we have, this security control web application firewall. It can protect our application for sure. We are putting them in front of our application, they can control requests, they can protect our applications, but it is not enough. This is a reactive security controls. You know, if you are only developer or maybe you are focusing on application security, you should know that we have some kind of security controls that generally I can separate them in two parts, reactive and proactive security controls. So about web application firewalls, this control is a reactive security control, is a sometimes firewall only on application layer that control HTTP traffic. So for these threats that we have today, it is not enough. We have siloed security teams, and these separated teams cannot work together. This is not about whole of the organization, this is not about whole of the companies, but for instance, about most of the cases when I go to an organization, I found that they have multiple separated teams that are working in development, working on DevOps, working on security, but cannot work together because this is the main issue. Because shift left is a concept and is a culture that we should implement that in our organization. So this is the era of patchwork security. And maybe our organization or our company is still at this stage. So we need to change that. And this is the main topic of this INFACT event. Look at this procedure. Look at this INFACT image. We have three main segments that we should consider about that. One is process, another one is technology, and another one is people. I want to add the top layer of this line. It should be culture. Please consider about the culture of your organization. You cannot connect these three parts to each other without considering about culture of your organization. And this is one of the most important failure of, in fact, failure reason of deployment of DevSecOps in organizations. So we have people, process, and technology. About people, it's back to your guys, your developer, security teams, your hackers, and also it backs to people that wants to use your application. So we need to consider about all of these aspects. I borrowed this slide from the structure of positive technology because now we are using that, in fact. About technology, it backs to the solutions, the security controls that you are using. And about process, it's interconnection between the process that you have, between the entities that you have in your organization. So I just want to illustrate that because it is really important to consider about each part. We are going to connect them. And before starting, moving further to new era of application security, just let's think about the meaning of that. Application security is some kind of process and practices used to help us to develop software in a secure way. So it is really important to consider about the approach of that. When we started DevOps, the main reason was to provide an environment to help organizations to speed up and optimize the producing of the application. So when we started DevOps, we use we use DevOps culture to optimize our product line. But it does not work because multiple bugs and multiple security issues demonstrated in production level. So we need an approach, and it was shift left. Think about shift left, because at the end of this session, I just want to know about your mindset about shift left. It is really important. Shift left is an definition. And it's back to considering to the start point of the issue, that is development. So we created DevOps. DevOps, in fact, DevOps birth was according to the previous slides that we mentioned. And now DevOps impacts CI/CD and the needs of shift left that we discussed. When we started DevSecOps to securing our DevOps pipelines, we should produce some new tools like SAST tools, DAST tools, SCA, and other components that we are using them. I know that maybe most of you are from application security segment, so I do not want to bother you with this basic information, but I just want to be synced with you. So how does it work? DevOps, in fact, CI/CD, that we created that to, as we discussed, to optimize our productivity. And we just said that it is not enough. We need shift left. And also, we introduced some tools that was, as I mentioned, sorry. As I mentioned, that was SAST. SAST tools are some kind of tools that do a static analysis security testing for us. For instance, you can scan your source codes, but this is not enough. In fact, scanning source code is not enough. Why? Because when you are scanning your source codes, it makes multiple false positives to you. It makes multiple tickets to development teams, and this is why that always they are skipping SAST trigger alerts. So if it cannot, for instance, optimize, it cannot be optimized, it is not helpful tools. So why and how we can optimize this pipeline with multiple security tools. Also, we have different tools like DAST, Dynamic Analysis Security Testing. DAST works on runtime level with your application. And this is, we will discuss about it in details. Dynamic testing, when we use that on runtime level, we want to find out vulnerabilities on runtimes that can affect user or that can affect system. And we have SCA that will find vulnerabilities in third parties. Just think about that. And infrastructure as a code. You found some words here, for instance, infrastructure as a code. Infrastructure as a code is a word that built around the last decades. Previously, we had some infrastructure that network engineers, system administrators, try to connect components together, try to deploy network infrastructure servers, but nowadays all of them are changed. We are using infrastructure as a code. So now infrastructure is based on codes and are vulnerable. So we need to consider about that too. This is the exact point that we can move further, and we can discuss about the second part of our discussion. The present state of AppSec. Believe me that in 2025, there are multiple companies that still are at the previous stage and previous era of application security and infrastructure. So this is why that most of the hackers still are interested in using traditional approach to hacking organizations. This slide is a simple pipeline of DevSecOps. We have separated DevSecOps to multiple parts, and we can now plan for our pipeline. We can plan for a specific sector that we need a security control to put in front of that. And this is a big picture, an HLD of DevSecOps pipeline. We have plan, code, build, test, release, and deploy. And still, it is DevOps. So nothing changed. We just are implementing security controls in correct point. And this is only the, in fact, most important matter. The correct point. You should try to find that. So we have multiple tools. We do not want to about that, and we do not want to discuss about these definitions. I just put them here for people that want to know about it more. But to be synced with each other, SAST tools are only focused on source code analysis. And source code analysis is the initiate point that vulnerability made. For instance, when a developer start to coding, start to building an application, this is the start point that one vulnerability can burn. So when we are using SAST, we are scanning our source code to find out a vulnerable block of codes. We have at least two approaches to finding vulnerability in the state of development of code. One is pattern matching. Pattern matching is the method that most of the SAST tools are using. They are trying to find out vulnerabilities according to something like regex, for instance. Just I want to simplify that. They are trying to find a vulnerable block of codes by pattern matching. When you are using this approach, in fact, your false positive will be increased. And this is why that it does not work in a high productive environments. Instead of SAST, we have another approach using IAST or IAST, that means interactive in fact security testing, that provides some cybersecurity testing on your source code in interactive modes. So they are calling application. Also, we have some kind of optimized SAST, like the tools that Positive Technology also provided. It is not only focused on using pattern matching. When you have a vulnerable code, and when your SAST tools detected that, it is not equal to you are vulnerable. It should be, in fact, test on your runtime. If this source code can be run on runtime and can be called by hacker, so it could be exploitable. So we have another layer that we need to define exploitability of this, in fact, vulnerable code. And this is really important. You can use this method to reduce your false positive. And you should consider about that. For instance, we have multiple open source and free tools that we can use them as a SAST, but it is not enough. We do not want to find out false positive. It will bother your development team, and you should reduce that. So we need to merge that with other tools. DAST is a kind of security controls that help your application in runtime level. This is a similar stage that your application is working, but still is in, for instance, testing, or still is on your production level. So you can use that. You can use that for testing the application that is live. You can work with that. You can call multiple functions, and it will provide multiple vulnerabilities that user can see that. So hacker also can see that. And about yes, as I mentioned, it's interactive application security. So it attempts to combine SAST and DAST. It is important. This is the best way, according to the recommendation of OWASP guidelines. This is the best way of providing a security control at the early point of your development environment. So you can consider about that. But now, our topic is not about these tools. These are some kind, in fact, topics that I just try to explain them. Now, I want to discuss about real-time security controls. We have at least, in fact, two stages, in builds versus in production level. Runtime production, threat modeling security and security champions will help your pipelines to reduce your vulnerabilities at the initial point of your development. So let's discuss about them. Threat modeling is one of the most important parts. But nowadays, we are using some near to static application. They are not dynamic, in fact. And we are using various methodology to designing our threat modeling. If you are interested in threat modeling, there are multiple references from OWASP, from Microsoft, that is Microsoft Stride. You can search about that. But nowadays, we are using all of these topics by our hands. We think about that, we test our application by hand. Maybe we are using some tools that automate them, but still is not enough. Let's go further. About challenges of our today's application security. Today's application security controls are not really helpful because we are in a paradigm shift. We are thinking about an era that all things are changed due to using AI. So we discussed, we have multiple false positive, too many tools, and not enough context. And the most important matter in application security is context. You should define your vulnerabilities in context. So let's see this pipeline. This is an architecture of DevSecOps and application security. Let's start from the first one, from the development. We discussed that we should consider about this part. This is the recommendation architecture of positive technology that's introduced to the market. We have development stage. We, as a developer, are sit here, so we need to start our protection from the start point, from the IDE, where we are coding. So your SAST tools should provide something for IDE that is a plugin, should be installed on IDE, and it can check your program continuously. And it should be connected to your, for sure, to your server. The next step is source code. Source code is nowadays is stored on your repository. So you need to automate this procedure. This is really important. Source code, we discussed that we have SAST tools. SAST tools are provided to analyzing your source code to finding vulnerability automatically. And after that, we have build environment. Before entering to your build environment, you should consider about multiple technologies that you have in build environment. But for this type, we have multiple open source libraries that we are using there. And also, we have multiple type of repositories that we can use. So we discussed that variation of technologies makes it difficult to create only one solution for all of the organizations. So we should consider about these things too. About build, we need to provide something that can protect our build environment. And after that, we have some images that we want to use them on our containerization environment. We are talking about modern application, and I just want to skip traditional one. So here, we need to think about container security. Container security is one of the most important part of this application security. I just want to mention that again, application security is not discussed only about software. It is discussing about infrastructure of application, about the procedure of producing application and protecting application, and also about testing that. So we have also deployment stage. The deployment stage, according to my previous sentence, we should consider about containerization and modern method of deployment of applications. So at the end of that, we have test and production. So if you are only focusing on penetration testing or checking the application that is live and in fact is in production or maybe your test level, you are only focusing on this part. And you have missed all of the security controls before that. This is why application security recommend to consider about each state and are providing multiple security controls for each segment. So you should consider about application security something like this part, something this pipeline model. And if you are only using a WAF in front of your application, you should consider about that. Still, you do not have any security controls in your pipeline. So you are protecting only the production level, and it is not enough. We will back to this scenario again. Let's see that. Application security tools for today's world can be something like that. I just mentioned two positive technology approach, and now I want to introduce another part. This is another model that you, as application security engineer, can consider about that. We still have the same concepts, but in different approach, in different way. So the demonstration is not important. This is about concept. The most important matters is that these tools are working together. So we have interconnection between them. Also, we do not want to put our security engineers to work only for these tools. They should work together automatically, and this is important part. You need to use automation as we experience in DevOps. So let's discuss about automation. Do you know about N8N? Have you ever heard about that? One? No one? Two? Three? No? N8N. N8N is, I just want to mention to these tools because it has a self-hosted free, in fact, tools, so you can use that for automating your workflows. I recommend you seriously test that. This is not about AI, this is not about future of application security, but this is the tools that must be tested by you if you are application security engineers. You can use these tools to automate your workflows so you can optimize that for your application security, for your pipelines, for your steps. So let's back to this architecture. For instance, this is about SecOps, security operations. One new issue has raised here. You can decide about that. We are only discussing about a simple workflow. Extract IPs and domain is one of the initial tasks you done when you are facing to this issue. So you want to extract that. After that, you want to check the domain or URL on a tool that is open and public, like VirusTotal, or maybe you prefer to use URL scan to scan that application. It's really simple. After that, we want to get the report from VirusTotal. And after that, now we have two inputs. We can decide about that. We want to merge these two reports, and we want to post the results to the further steps, and we can decide about the next step, how we want to do. This is an approach that you can do that by your hands. It's clear. But you can automate that freely by using these tools. You can integrate all of the APIs. You can integrate all of the tools that you are using in application security. And these tools can help you. For instance, you are using, as we discussed, SAST tools. SAST tools can provide source code scans and can provide reports for you. You can integrate the results to other parts and further steps, and you can decide about all of the procedure automatically, and it will be reduced your headache. So at least we have this part. Let's back to our intelligence into security. Now we are using ML. It's popular. It's, in fact, common tools. We always use that. There are multiple methodologies that you can use ML, even in your laptop. If you are using MacBook, for sure you can use ML. And also, if you have a high compute CPU on your laptop, you can test it with Ollama. I don't know, have you ever tested that or not? Yes. So Ollama can provide a self-hosted laptop, a self-hosted, in fact, framework that you can run LLM, large language models, on your laptop. So you can experience something that ChatGPT or DeepSeek is providing for you. But for sure, it costs you because it's use your GPU and CPU. But it is optimized to be run on your laptop. Test that again. You can integrate this kind of solution, like using LLM with n8n to automate your procedure, your decisions. I want to back to the architecture of application security and DevSecOps that we discussed. And we will see that how using these tools can reduce your headaches. So nowadays, when we are discussing about vulnerabilities, this is really important about prioritization. We have two, in fact, vulnerabilities. Which kind of vulnerabilities is important for us? We should consider to which vulnerabilities. These are important part of your work that you should decide about that. Business want to decide which kind of risk and which kind of vulnerabilities should be eradicated. Or maybe you prefer to accept some kind of these vulnerabilities or skip them. So about anomaly detection, this is a part that we cannot provide that as a human. For sure, we cannot read all of the code lines. We need AI. And false positive reduction is another point that we need that, and it would be happen only by using AI. So now ground is shifting. If you are an application security engineer and you have focused only on using current tools, it is not enough. Believe me, it is not enough. And the game is changed, and you have to be synced with this new era, and you only maybe have 1 or 2 years. All of the ecosystem will be changed by using AI in application security. So we have automation now, but we need a smarter automation. Some kind of automation that can decide. Some kind of automation that do not need us to decide about the procedure, about the next step. And this is the start discussion of AI agents and using AI agents in our application security pipelines. So when we want to discuss about using AI agents, maybe we need to point to this, in fact, item. In fact, we are bottleneck. In your future of application security, for sure, humans are bottleneck. And for sure, you do not want to remove humans. We need to optimize them. We need to optimize the task that security engineers has. As a security engineers, we should consider both that we are the bottleneck of this wall of this procedure, and we should reduce our manual task, automate that, and automation is not enough. I discuss about intelligent automation. And this is only happen by using LLMs or AI in your procedures. So we need to work with a smarter, in fact, automation. Let's back to some information. Fixing a bug in production is 6 times more expensive than fixing it during development. So business wants to reduce their cost. So security engineers are not important, believe me. I'm a security engineer, so we are not important. Business is matter. So we should provide environment that can reduce the whole of cost of the business. And this is the next task that we, as a security engineer, should consider about that. Another data. Average cost of a data breach in 2024 was 4.45 million. Average cost of a data breach. As a security engineer, I can promise that we cannot reduce all of the data breach. It is not possible. So we need powerful, smarter automation, and this is AI. An organization with a major DevSecOps program reduced breach cost by an average of 1.68 million. This data is from IBM. About application security and business, I can mention to 35% of organizations that integrate AppSec early in the SDLC can reduce security-related costs. So it is important for organization. They are thinking about that. They are investing on AI. I don't know, have you visited JSEC or not? JSEC is an exhibition like Positive Hack Day in Dubai. One important part of this exhibition that is discussing about the future of, in fact, security in the world. They are discussing about using AI in this segment. So as a SecOps engineers, we should consider about that. I do not want to only mention two numbers, but 74 days. Security automation reduced breach detection and response time by 74 days on average. And this is really important for businesses. So let's start about emerging trends in application security. That is the third part, and we are near to close our topics. AI, as we discussed, enhanced, in fact, I'm so sorry. AI-enhanced SASC and DASC tools nowadays are available. Also, you can integrate LLM with your SASC tools, so it's obvious. I just referenced to using Olama. You can use Olama. There are multiple LLMs that are trained, that are tuned. You can use that, you can integrate that, and you can use anything to integrate the whole of this ecosystem. So you can build your own AI-enhanced SASC tools. LLMs for threat modeling can help you. We discussed that threat modeling is, in fact, is an important part of the ecosystem that we discussed about that. But we in fact did that manually. Nowadays, we can use LLM to detecting vulnerable parts, to detecting threats, and after that, to decide what can we do. And vulnerability triage, in fact, nowadays can be fully automated. You do not need to work on vulnerabilities to fixing them. You just need to create a proper automation ecosystem for yourself. And all of these ecosystem could be free because there are multiple open source tools that you can use. About smart integration, as we discussed, event-driven workflows nowadays are tools that are free. You're free to use that. You can self-host anything, and also they are providing, I guess, some, in fact, on the cloud service. I'm not sure about it, but I know that they have. So you can use that. You can also self-host that. And there are multiple templates for your SecOps and application security. You can only use community-driven recommendation of anything to start your automation by these tools. About copilots and LLMs, maybe you have experienced that. Nowadays, coding are changed. No more programmers are not using developing by their hands, for sure. They are using AI. They are generating codes by using AI, by using LLM. So it's obvious. When they are increasing their speeds, for sure the vulnerabilities also will be increased. So how we can control that? We need to tune our detection controls with these LLMs solutions. About AI augmented. When you are discussing about LLMs using large language models in application security, we have another part that is augmented, in fact, AI augmented. For instance, you want to enrich your LLM with your data. you can use the RAG systems, and you can increase the knowledge of your AI, your internal AI, by external information that you are providing to that. So this is important. As a security engineer and as an application security engineer, in fact, you should consider both new tools that are providing nowadays. So, about the trend summary, we just want to visualize again. We want to back to the architecture that we have. So this is the start point of the future of autonomous application security. How we can automate that, how we can make it smart. We learned that we can use LLMs. You must use that, in fact. And you can integrate all of these workflow by using free open source automation tools that we discussed. So let's back to this question again. Who are the parties to this war that we call it application security? The future of this war is between human and human that we have now, from hackers and defenders, or between the hackers and AI detection tools. We should consider about that. Or this war had another parties. Red teamers nowadays are using AI agents. So maybe the future of application security and the future of security controls that you should consider about that is between AIs and AIs. And we just are designing the procedure and deploying that. So I just want to invite you to answer this question at the end of the session in next 4 minutes. What are AI agents? AI agents are simple, small parts of an ecosystem of artificial intelligence that can decide, that can be creative, and that can act as a human. They can decide which part of the code is vulnerable, and if they found this vulnerability, what should they do? This is the exact thing that nowadays we are doing that. So we are implementing AI agents in our ecosystem. There are multiple tools that we can use that, free and commercial, to providing AI agents. AI agents in software development is also available, and you can use that. Agents are coding. Still, programmers are human, but AI agents are coding. They are generating codes. They are the greatest debuggers in the world. They are also the greatest red teamers in the world. Building microservices and end-to-end services nowadays are, in fact, implemented by using AI agents. You can distribute your AI agents on your ecosystem, and they can decide, they can deploy, they can be used in your infrastructure, they can deploy your Kubernetes, they can control your pods. So this is the start, in fact, gate of the next era of application security. And this is the point that we should consider about that, securing AI agents, a new topic of application security. And potential risk, vulnerable codes, supply chain, and attack surface. These are new threats that your company will be faced with them if you are using AI agents. So let's back to this architecture. I just want to demonstrate that again. We have still the same concept, SAST, ICS, and ISC. Now we know that we can use ML, machine learning, and AI. Also, we can distribute our AI agents in this architecture. And now we can integrate the whole of the ecosystem. So back to this architecture, this is a big picture. This is not about detailed design. So back to this picture, we can integrate the task of AppSec and dev team together. We have now an ecosystem that most of the tasks are done by AI agents. So we still have red teamers and hackers. The red team and hackers are scanning, exploiting, and hacking the application on behalf of AI agents. And about blue team AI agents, or maybe we can abstract that as SecOps team, They are detecting, patching, and blocking. So these are the operations that we are doing that. We are doing that by human. But I guess in next 3 years, for sure, human tasks in this regard will be reduced. Will be reduced, at least 80% of these tasks will be automated. And finally, AI generation secure by default infrastructure templates. So we do not need to consider about infrastructure. All things are automated. And about this question, human versus agents, in fact, AI agents, which and who wins? So I want to invite you, think about the question that we had. What was the, in fact, what is the parties that are involving in this war? This war is between human, or AI versus human, or AI versus AI. This is the question that I have. Thank you for your time. And now I'm free to answer your question. But first, I invite you to answer this question. What, in fact, are the parties in this war? And we want to give a little gift to a best question, and you will, in fact, decide about the best answer. So I just want to invite you. Who wants to participate? I guess you are really interested in AI, LLM. Maybe you can participate. And you, for sure. No comment? What is? What? Yes.
AI agents versus AI agents.
Sorry, I cannot hear. I think it's turned off.
1, 2, 3. 1, 2, 3.
So on both sides will be.
We change.
All right. On both sides there will be both AI and humans separated in two big teams: the blue teams who defends and the red team who attacks. And the fight will be disastrous for both. As a constant race with black hat hackers using AI to automate finding exploits, and the white hat hackers using AI to find solutions to those vulnerabilities. I think it's fair to say that both machines and humans will unite in this big war.
I see, thank you. And I guess my friend wants to participate too. Use this microphone, please.
I guess he already asked everything what I want to ask you too, but I guess AI agents versus AI agents is a pretty obvious situation in future, but I hope so people still participate in this system to save work for us, at least for a little time.
And I guess we need microphone here.
Hello, thank you for your discussion. I was really agnostic about the idea of using AI in blue teaming, but your take about why we shouldn't use it while red team already does it is astonishing. For me, you probably know some news about Copilot in Microsoft repositories, as it was a mess. So I fear that by including AI in our blue team processes, we will actually make more work for human cause. We need to validate potential false positives. What do you think about it?
In fact, as you mentioned, using Microsoft, for instance, Copilot, nowadays they are reducing the tasks that programmers are doing. So I just want to make an example from a Russian-based company, Telegram. Do you know how many people work in Telegram as tech?
Around 50, yeah?
30. And do you know what, in fact, how many people worked in previous Instagram when Meta decided to buy them? Do you have any idea about the earliest stage of Instagram? When Meta bought them $1 billion US.
Wow.
13. So they are using automation. And I just want to refer to the Copilot and other AI-based generating tools. They will, in fact, be implemented. We cannot remove them. We just need to decide what kind of AI agent we should choose to implement in our business lines.
But you know, the case of Meta and the case of Microsoft are similar, because Meta AI makes a Llama, and Microsoft makes Copilot, and it's their public story of using them for advertisement. So for our mere people who doesn't make some large language model, it's like a challenge. Like for them, it's no option. We need to proclaim that we have AI and we use it and everything is fine, but actually no. But for us,
yes, for sure, we will not remove human, in fact, roles. We humans will be architectures.
yeah.
Yes, this is the matter. Human will be the architecture, and they will design the ecosystem, and they will decide which AI agent should be implemented in which part, and they can control all of the system. So this is the most important part. We need to decide which kind of, in fact, contribution of AI we need to use. We should decide. For sure, you are right.
I think in most cases, people will just try to put everything to AI, for example, to ChatGPT, for have a final decision, and it would be everything, and no one will validate it. I don't know.
Yes, I just, to answer your question, I just mentioned two free tools like Anything. You can make it easier to decide. Anything is not AI, Anything is integrator. You can use Anything to integrate your AI engines. For instance, when a vulnerable code is now detecting by your SAST tools, it can be triggered and it can be decided. But you need to put your AI agents, integrate that to Anything, and Anything can decide how it can work. You will train him how it should decide. So this is your role. You should train that, you should optimize that, and you should only think about that what is the next architecture that you want to deploy. This is the future of your role, in fact.
So some interactive and based on interactions process, yeah?
Sorry, I did not get.
So we need to do it step by step, not trying to put everything on it.
For sure, you cannot remove your current ecosystem. Absolutely, you need a step-by-step roadmap to integrating AI agents with your ecosystem. If you still do not have application security, for instance, or automation, the first step could be using the architecture that I just shared with you. You can use that, you can design your procedure, and after that you can integrate a step-by-step automation. First, focus on automation. After focusing on automation, absolutely you can integrate your AI agent to this ecosystem. And there are multiple integrators that you can use. So it's a roadmap, in fact.
Thank you.
Thank you.
Yes, I'm here. My name is Tatiana. Thank you for your discussion. And you asked us a philosophical question, and I'd like to ask you too. We have two popular questions in Russia: what to do and who is to blame. And let's imagine a situation. We have a lot of AI-powered tools, and one tool missed some vulnerability, and it went to production, for example, and cost some money and reputation to the company. And the question is, who is the blame and who is responsible for this event?
Yes, the second question, who is responsible for AI? Generally, invite you to use current, in fact, AI engines like OpenAI or others if you are a critical infrastructure, if you are a critical business. I never recommend you to use them and integrate them in your ecosystem, and then you can only focus on using your self-hosted and on-premise AI agent according to the frameworks that I just mentioned, like Olama and others. So if you are an enterprise, mega bank, and important industry, you should in fact implement your LLMs and you can rely on that. So you and your, in fact, organization are responsible for this AI. You should not share your, in fact, information with public AIs. But about the first question, in fact, I did not get the point, and if it is possible, please.
If AI tool set vulnerability is false positive, but it is true positive, and it goes to production, who is the blame of this situation?
Yes, false positive and false negatives, in other words, is a part of our, in fact, mission. I just mentioned to my friend that we do not want to remove, in this era, in fact, we do not want to remove the role of human. We still are working. We are supervisor of our further AIs. So you cannot do that. You cannot remove the role of human, the first point. The second point is that when we are discussing about implementation of AI agents, for sure we should predict about some bugs. We cannot never eradicate all of the vulnerabilities before the production, because we have a topic in application security that is related to business logics. And business logics are not something that is related to code. They are logics, they are procedures. For instance, when you are developing your program, this is the topic that is one of the WSCG, in fact, OWASP Web Application Testing Guides. This topic is a reference that you can read. When we are discussing about application security, we can categorize them. Some of the bugs are bugs that when you are developing that, or some of the bugs will happen on runtime, but some of the bugs are in your business logics. Nowadays, this type of AI agents cannot remove them, cannot detect them. But I guess you can train your LLM to decide and think. When you are discussing with ChatGPT, ChatGPT will think and decide about, in fact, your question. So you can do the same. You can, for instance, consult with your internal AI, and they can decide about threats, as I mentioned, about the threats that can, for instance, about the risk that can threat your application and business line. I guess nowadays we cannot remove 100% of vulnerabilities. It would not be happen. But for sure, you need still you have multiple controls for detection. They are still alive. You can rely on them. But I guess more than 80% of this procedure can be automated, and the task of human can be reduced.
And the last question.
Thank you for your presentation. My question will be third concerning false positives, and I will ask you, please elaborate on the role of the human here, and I will be more specific. Let's say I have 100 results of static analysis, and I have this tool and do not trust it fully, so I have to triage it. And then once AI agent or ML agent process it, I still have 100 errors, and I still need to manually check them, triage them. So I don't get what the profit here. This will require the same amount of effort, isn't it?
No. In fact, it will be changed. For instance, let's make it easier for you. Your SAST tools will find something that is vulnerable. So it will notify your developers. Developers should consider about the bug. As you mentioned, you should consider about the bug. You should check it by your hands manually. Am I right? So now let's imagine about the ecosystem that bug is detected by SAST tools, but is not reported yet. It will be checked on runtime by another agent because agents decide that now I want to check it on runtime, but IAST tools. After that, on runtime, for instance, AI agents can find that this vulnerable block of code is not exploitable in runtime. So this is a really important concept. If your vulnerability is only your source code and it is not exploitable, this is not vulnerability. This is only bad coding practice. So AI agent can help you to reduce your tasks because it can decide that this is not a vulnerability. Okay, it can be ignored.
Thank you. I missed the runtime part. That's the answer for my question. Thank you again.
Thank you. And
it was the last.
Sorry, I know
last
that.
question. Yeah, we have. Unfortunately, we have no time for additional questions, and now you need to choose the best one. What was the best question?
I want to invite them. What do you think? What was the best question? Do you want to participate? Yes, in fact, I think this one I liked. In fact, I like that approach and I like the questions.
Your prize.
But thank you for all of the questions and contributions that you had. It was really, really helpful. And just I want to invite you again. If you have further questions, I'm available in PhD today. Thank you.
Стас, подойди, пожалуйста, и получи свой приз за лучший вопрос. Похлопаем Стасу.